provided and produced by it, and obviously they must be able to use it via the support mechanisms and devices. So these are basically the categories that we have included and worked with in order to analyze each technology in the ETSI group. But as we're talking about new technologies, the technologies that we have analyzed are new, so the generic standard did not always take into account the needs of these new technologies. There's a basic example, which is that of tactile interaction. Tactile interaction is going to be one of the protagonists in the future, because it allows us to think about other things, to concentrate on other things. Is it useful to have a vibration system in a meeting? On our mobile phone, for example, well, it's really helpful, so nobody else knows when our phone is ringing. And we've been able to look into these kinds of systems in much greater depth, and the ISO 9241-920 is the guide on tactile and haptic interaction. And many of the knowledge about ergonomics, the relationship between people and systems, and how to design the system to adapt to people's needs, well, these are found in scientific articles. Obviously, we've had to look at the literature in order to understand the developments in the fields in which there are no applicable standards at the moment. If we come back to tactile screens then, touch screens, what's the benefit of these tactile screens? Well, they offer alternatives for visual and audio output. We could say that this is similar to a braille that's used by people to understand the output of their computer, for example, but also, as I said, something which allows somebody without visual impairments to perceive the output without having to pay attention right then to what the system is generating. On the other hand, according to the study of manufacturers, writing on a mobile phone is not satisfactory at the moment. There are studies that have shown that, for example, with an iPad or a Galaxy Tab, the buttons that we use to write an email or a phrase to search in Google, if there was a certain degree of if the relief it was raised, it would be more efficient. We'd be more precise. So this elevation of the touchscreen could be very interesting. So what have we done? Well, we've used these accessibility categories, these clusters for the ISO standard. We've used them to analyze the accessibility needs for these tactile screens on a phone or a computer. And we've seen that there are basically three categories. First of all, we have to look at the perception of the existence and location of controls. For example, regarding the specific needs that we found, somebody who can't see very well has to distinguish between that tactile output that's being generated and a brand or some kind of logo, decorative elements. For example, if my phone has Nokia and it's raised lettering, well, the user has to know that that's not information, that's not output. And what would a blind person be able to do to understand the output of a mobile phone? Well, a blind person would have to investigate the surface of the touchscreen to find the output. We have to help the user to be able to do this without unintentionally activating any control. And then there's a new category which was not contemplated in ISO, because one of the conclusions we've reached was that the ISO standard says practically nothing about tactile perception, tactile information. And we've informed ISO about this because we feel that it's necessary to include an additional category regarding the perception of tactile information. Obviously, they knew this already, they were aware of this, and they're already working on the identification of user needs when it comes to tactile information. It's very easy when you've got your phone in your pocket to know that someone's calling, because a very basic, simple tone informs us of this. But what happens, for example, if we're wearing a belt? There are prototypes. Here on the right, we can see a prototype of a belt which incorporates a GPS navigator, which is tactile. Now, this could be very interesting because I wouldn't have to have a screen in my hand to know which direction I should go in. So, this tactile belt could incorporate a more complex coding system than the one we're used to in a phone, for example. We would probably, well, our body is very sensitive to tactile information, but it also depends on the part of the body where it is applied. So it would be necessary, first of all, to have that activation, have that tactile stimulation in a part of body where we would detect it. And we need to have signals which enable the user to distinguish between different messages. For example, when it's telling you you've arrived or you're near, but you have to turn right at the next crossroads, or you're completely lost, turn around and go back. So these messages, they have to be coded in order for the system to be intuitive for users. And to achieve this, certain standards have to be established. And I want to say that it's not just been tactile interfaces that we've worked on, but also visual enhanced reality. For example, well, when I came into the room, I saw somebody with some glasses. We could say they're quite sophisticated glasses. I don't know. I've not read the program in detail, but it looked like a device which incorporates information. These systems combine real vision with information that's generated by a computer, and I just wanted to give you this example of problems with these kinds of systems. For example, logically, I've got the background which changes, and here on the screen we can see different combinations of colors, lettering, and contrast. One of the main characteristics of visual perception is that we need good contrast between the information and the background of the screen. So this is something that needs to be taken into account when we are designing interfaces based on enhanced realities. Here we've got more cognitive elements, for example, ones that allow a plumber to find a hidden problem in the tubes that run around the room. So, by way of conclusion, I would propose the following. And now I would like to give the floor to you to respond, criticize, contribute to these conclusions. So the roadmaps that have been discussed, I have to say that they've been discussed in great depth, together with the industry, with researchers, users associations, And by means of the ETSI standards, what we do is we get a list of interested people, and through these lists we notify them of draft versions so that people can write to us and share their opinions, their views. We also organized a workshop last year in Stockholm involving 25-30 people from all over Europe so that we could hear their comments, their views. It was very interesting. And another conclusion, no doubt many comments have not been included because the document hasn't been disseminated perhaps as widely as it could have been. But one of the conclusions we reached was that it was necessary to take into account design for all criteria at an earlier stage, because people who are working on tactile screens, for example, should be aware of accessibility needs, just as they take into account battery consumption, mechanical resistance, and so on. I think accessibility is something that should form part of the technical requirements, the core requirements that are being taken into account from very early stages, because this will lead to increased quality. And no doubt accessibility standards need to be gradually modified in order to make room for new accessibility characteristics